Hello, Ms. Stuckel here. So what I want to do today is take a few minutes to go through how do you go from the name of a chemical to its formula and its particle diagram. And I'm going to use a couple examples to do that. Now, something you're going to need to have handy when you're going between names and formulas. On the main course page in Schoology, there is a chemistry formula sheet. And this is a really important tool. And in fact, this is something that I'd let you use on all of your assessments. So, the first thing I'm going to do when I'm figuring out the formula. So I've got a name right here. Lead, and then this is a Roman numeral 4. So it's lead 4 oxide. I'm going to go to my chemistry formula sheet, and I'm going to find lead 4. And it gives me the symbol and the charge for lead 4. So lead 4 is Pb, and then it has a charge of positive 4. And then I'm going to do the same thing with oxide. So if I look on my formula sheet, oxide is going to be a capital O with a -2. And I should mention, it is really important to keep the capital and the lowercase letters separate. When you have a capital letter followed by a lowercase, that means that you're talking about a single element. So every time you have a capital letter, that tells you there's a new element showing up. Now, for the formula, we want to be able to have the total charge add up to 0. So if I've got a +4 and a -2, I'm going to need 2 of those -2 charges to add up to a -4. So my formula is going to be Pb, and then I need 2 of those oxygens. So it's going to be PbO2. And then this 2 is what's called a subscript. It means that there's 2 oxygens attached to this lead. Now, that part you probably got exposed to in Chemistry Essentials A. This next part is new, and this is something called a particle diagram. This is going to be a really important tool for us as we start thinking about chemical reactions. And what a particle diagram shows is it shows us the individual atoms in a chemical. So what I would draw for this particle diagram, I'm going to do a circle with a Pb inside to represent that lead. Now, that Pb doesn't have any subscripts, which means there's just one lead atom in this molecule. So I'm just drawing a single Pb. But for oxygen, there's 2 oxygens. And so I need to draw 2 circles with an O inside to show those 2 oxygen atoms. So right here is my particle diagram for lead 4 oxide. Now, I want to show you an example of one that gets a little more complicated. And that's aluminum carbonate. So the aluminum, according to my formula sheet, is Al with a -3 charge. And carbonate, this one is in a different section of my formula sheet. It's down here with these polyatomic ions. So that just means it's a group of atoms. And so it's poly means many. So polyatomic means many atoms. And they tend to come in groups. So this has a -2 charge. Now, a little bit of a trick that you can use with something like this. This one, it's harder to figure out what charges I need than it was with the lead 4 oxide. But I can use a trick called flop and drop. So I can take this -2 and make it the subscript for the aluminum. Oops, and actually this aluminum, that should have been a +3 charge all along. I'm sorry about that. Now I'm going to put this carbonate in parentheses and give that a 3 subscript. So that's telling me that I have 3 of everything inside. Now, if I have 2 aluminum atoms, and each aluminum atom has a charge of +3, this would be a total charge of +6. If I have 3 of these carbonates, and each carbonate has a charge of -2, that's a total charge of -6. And so my charges are still adding up to 0. All right, now for the particle diagram. I'm going to go ahead and draw 2 of those aluminum atoms. Now, when we do a particle diagram, even though this carbonate tends to stay in a group during chemical reactions, we're going to want to still show each individual atom. So I'm going to do a C, and then there are 3 O's attached to it. And then I've got 3 of those groups. So I'm going to draw the same thing again. And then I'm going to draw the same thing once more. And it doesn't matter where I'm putting these, as long as I've got a total of 3 of those carbonate groups. So this right here would be my particle diagram for aluminum carbonate.